Good morning, good afternoon, everyone. On behalf of Power Sun, I warmly welcome you all to today's webinar. Thank you for joining us and for taking the time to be part of this important discussion. Before we begin, I would like to mention that Mr. 𝗂𝗏𝗏, founder of Power Sun, was scheduled to open today's meeting. However, due to his travel commitments, he is unable to join us at this time and has asked me to convey his warm greetings and best wishes to all the participants. We are pleased to host this session together with our valued partner Sungrow. In this session, we explore a topic that is rapidly shaping the future of energy in our region, driving sustainable growth of C&I and BESS in the GCC. Today, we will be briefly touching upon the three important aspects: current technology, market trends, and how Power Sun together with Sungrow is enabling this transition. And this is something you will clearly realize by the end of today's session. As we move forward, I'm delighted to welcome Ms. Ola, the Solutions Manager from Sungrow. She will take us deeper into these solutions, covering technical details, product applications, real world use cases, including how these systems ensure reliable power, enhance safety, and maximize returns. Also, let me please mention that we will also be providing a certificate of participation to all who joins and stays until the end of this session. Also, the Q&A tab will be opened. You can you can shoot out your questions during the session, but the Q&A session will be opened at the end, where we will be happy to answer and address all your questions and queries. So without any further delay, it is my pleasure to welcome Ms. Ola. Thank you, and over to you, Ms. Ola.
Thank you, Sinu. Good morning, everyone. Thank you for joining us on today's webinar session. It is an exciting topic indeed for the region, because earlier, I would say back in the days, few years ago, the GCC was mostly relying on on-grid applications and on-grid installations, as the grid is stable in the region. But recently we have seen also an expansion and growth in the interest when it comes to the energy storage solutions, especially on the C&I level. So when we're talking about the C&I level, that's the 400-volt systems with energy storage. So we have recently seen the policies in Abu Dhabi changing, introducing the energy storage policies as well, both on the commercial, industrial, and residential segments. And also in Bahrain, recently also the regulation has changed from net metering to net billing. Also that has shown interest when it comes to the energy storage applications and solutions. And also the other GCC countries, especially Saudi Arabia, started also way in advance. Qatar and Kuwait are also now joining this energy transition vision. So diving deeper into merging the power with profit, today we are going to introduce what are the solutions on the C&I level, on the C&I segments that are suitable to cater for the applications in the region when it comes to net metering, or even some are pure off-grid applications, some are mostly based on time of use. So basically the main anxiety that we face in the C&I BESS segment, or why is there requirements behind the C&I applications. So number one is, of course, is the high electricity tariff rates. Also complex C&I loads. Some of the C&I loads maybe in the manufacturing industry can have very high inductive requirements. Sometimes also perhaps the end user has a specific load approval from the government and he wants to add more in future, but this plot is limited to a certain capacity or a certain load size. So we can add that, which called demand charge as well. That can be added on the C&I BESS. Load shedding. So we have witnessed a lot of countries in the Middle East and Africa region that have load shedding. So load shedding means when the grid is not able to support the whole load. Perhaps the load have increased. The population, of course, is increasing, so the load increased beyond the grid capabilities. So that can be extended by installing solar systems or renewable energy systems to support the grid. So the load shedding happens when different areas will have different schedule. Perhaps the electricity will shut down for 2 hours in this region or in this area, then another 2 hours in the other area. So there is a load schedule where the load will go off. So here the solar or the renewable energy sources can jump into the picture and support during this load shedding hours. Lower power quality. So this when it comes to the power factors, as I mentioned earlier, some of the loads, perhaps highly inductive, high starting current, there are some loads consuming reactive power. So the C&I BESS systems as well can support with increasing the power quality, injecting reactive power and increasing this power quality. So over here, we are having the pathways and the applications of the energy storage systems on the commercial and industrial segment. So these systems can support us. I'm highlighting in orange is the parts that are mostly related to the GCC area, but all of these applications can be supported using Sungrow C&I BESS systems. So number one, which is the most common in the GCC area, when we have stable grids, sometimes we want to maximize our self-consumption. Maximizing the self-consumptions, this means that the grid is stable. However, I want to increase my reliance on my PV system. I want to reduce my reliance on the grid. I want to reduce my electricity bills. So this is what we call maximizing the self-consumption, where the priority will be for the PV system. All right, then the second priority is to discharge my battery to support my load. And when the battery is fully discharged, then I rely on the grid. So our concept here, the grid is stable, but we are reducing our reliance and dependence on the electricity grid. We are reducing our electrical consumptions and bills, and we are relying more on our PV system and battery. Reduce demand charge. So this is the point where you are having demand, but perhaps it increases over time, or you added more load on in future. So you can install your solar energy storage system to power up and take the demand of these loads. Emergency backup. In these situations, in case there is load shedding or there is emergency or urgent grid failure, also the system will be there to energize and feed the load using the battery. Time of use, and this is specifically for also countries where there is a specific peak hours where the electricity price goes up. For example, from 12 to 2 p.m. Perhaps that's a peak hour where most of the electrical consumption and the users are using their home appliances. So the electricity price increases between 12 to 2 p.m. So we can also set up the system and schedule it to work based on the time of use. So for example, from 12 p.m. to 2 p.m., the system can inject and discharge electrical power from your battery to your load. And perhaps there is an off-peak time as well. During the night time, there's not a lot of electrical consumption. So if the electricity price comes down again, we can charge the batteries from the electricity grid. So over here again, the electricity grid is stable. However, according to the peak timings, the tariff rates are changing. So all of these applications can be met with using Sungrow C&I systems. So now we have recently introduced a new player to the market, which is the DC coupled solution. So earlier we had the AC coupled solution, which is, we call them the power stack. So the AC coupled solution is a cabinet that has the PCS, power conversion system, and has battery racks as well inside. And it works with the PV inverters. So the PV inverters will convert DC to AC, injecting into the point of connection, then your batteries are AC coupled. You can install it on the same point of connection. So this is very suitable for retrofitting. Perhaps you already have a solar system installed, but now maybe the regulations have changed and you want to include C&I energy storage system. So this is very simple to add. So you will just add the energy storage system on your point of connection, which is AC coupled. On the other side, the new addition is the DC coupled solution. So now we have a hybrid inverter with a capacity of 125 kilowatt. So this hybrid inverter has two outputs, AC output on grid and AC output as an emergency port. So this we can connect also with the Power Stack series, but this Power Stack series will be different. It will not have a PCS because the inverter is already hybrid. So it does have the features of the power conversion and charging and discharging the battery. As we can see here, this is how the AC coupled system look like. So it's a modular cabinet. It's IP65 rated. It's also liquid cooled. The PCS is on the top and the battery racks are on the bottom, and then the AC distribution box is on the bottom side. So this cabinet, it comes with 257 kilowatt hour actually, that's the usable energy. And we have also the 517 kilowatt hour usable energy, which is the 510 CS. So one cabinet is 255 and two cabinets will give us 510. PCS capacity is 125, as we can see over here. So suitable for 2-hour systems and 4-hour systems. So both of those models are actually fitting into the application scenarios that I've explained earlier. So we can select our energy storage capacity and PCS according to our application. Here is a simple single line diagram or connection scheme of how the system will look like in reality. So we can see over here, we have our PV system, PV modules, PV inverters connected to our AC distribution box. And then the power stack or the AC coupled C&I BESS system can be just installed on the same distribution box. So it's very suitable for retrofitting or later addition to the system. And of course, we can have diesel generators, the grid and the load on the same point of connection. So the advantages of this kind of systems is, first of all, it's suitable for non-linear equipment and unbalanced three-phase loads, because this kind of system can provide unbalanced output on the phases as well. So if one of the phases is like 30 kilowatt, another one is 25, and another one is 10. So we can, the system is very smart. It will adjust its output according to the unbalanced three-phase loads. Also the voltage flickering. So in case of weak grid structures, we are able to support this kind of applications, and also loads with high surge current or high inductive starting currents as well can be supported with the C&I BESS system. So it leads grid C&I grid forming. So when we say grid forming, that means that this solution has a feature of forming a standalone grid. So if the grid even goes off, this system will establish its own voltage and frequency, and it will create its own grid. That's why we call this feature or function as a grid forming. So our PV inverters will continue to work and power will be injected to the C&I, which is the energy storage system, and to the load side as well, ensuring stable and secure power supply. All right, intelligent energy storage, keep your profit rolling. So now we're talking about how the C&I BESS systems can also, the latest innovation, can also reduce our capex cost. So compared to our previous series, which was three-phase, three-wire systems, there used to be an isolation transformer in case of on-grid, off-grid application. But now this is upgraded to three-phase, four-wire system. So there is a neutral cable here as well to be connected. We are eliminating the requirement for an isolation transformer, therefore reducing the capex cost initially. And also, as I mentioned, it withstands high surge current loads and also addresses the load imbalance between the three phases. So it's very durable. And when it comes to the energy storage itself, the battery racks, we have battery cell level monitoring. So the battery cell level monitoring allows you to see if there is any fault happening on the battery side, there is a high temperature, there is some kind of arc. So there is active monitoring and active protection as well, where if there is any major alarms or hazards, the system will shut down itself and create an alarm notifying the end user or the installer about the fault and what's the reason of the fault and how to correct it. Also, there's a fire system and a fire suppression system, actually, fire extinguisher inside the cabinet itself. So the advantage of the liquid cooling, I know this is a very recurring question. What's the difference between the liquid cooling and the air cooling? So the air cooling is the normal systems where we are having fans or HVAC systems to cool our energy storage, but it consumes a lot of energy. So there is a lot of consumption when it comes to the energy itself to cool the system. But the liquid cooling on the other side, it's AI powered. So it actually checks the realistic energy storage system temperature and activate itself accordingly and regulates its temperature according to the battery racks itself. It will also ensure that the battery cells do not have more than 2.5 Celsius in terms of cell temperature difference. So because the higher the cell temperature difference, the lower is my efficiency. And most probably that my system will follow that cell with the least performance. So that will bring the whole rack performance down. So with the AI-powered liquid cooling application, it actually reduces your electrical consumption when it comes to cooling by almost 33%. Because it's AI-powered and it regulates its temperature according to the battery rack and battery cells temperature themselves. So the system is also IP65 level protected on the pack level, overall pack level, and IP66 rated protection for the PCS, the power conversion unit itself, and another IP55 rated enclosure for the outer case for the rainy seasons. The system is C5 rated when it comes to the anti-corrosion protection, so it can be installed in the offshore areas. And also it has surge protection. Surge protection is the lightning protection. It has AC SPDs type 1+2, so it's triple lightning protection, higher sensitivity and higher accuracy to protect against the harmful current flowing in case of lightning strikes. Also high humidity, so anti-condensation from 0 up to 100%, which is very suitable and durable for the GCC area specifically also, because if these systems, which is most probably they will be installed outdoors, so they can be protected against the sand and the dust, the high humidity as well. The GCC region is characterized by high humidity as well, so it can withstand up to 100% of humidity. Moving into the DC coupled solution, which is our newest innovation. So we have the SH125CX, which is a hybrid inverter with 125 kilowatt output, and it comes with a battery as well. As you can see here, it's similar to the power stack. However, the difference is there's no PCS here because the PCS is built inside the hybrid inverter version itself. So we have the ST245CS. So in case of on-grid applications, we are able to install up to 24 units in parallel. 24 units in parallel, giving us up to 3 megawatt system. And each inverter can be connected into a 245 kilowatt hour battery system, giving us almost 5.9 megawatt hour. Again, one of the questions that is recurring, Why are we using the energy storage in case of on-grid applications? We say we can connect up to 24 units in parallel. As I mentioned earlier, it's because we're trying to maximize our self-consumption, maximize our reliance on our own PV system, reduce our reliance on the grid, therefore reduce the electricity bills and the electricity consumption. And we can connect up to between 2 to 5 units in parallel in off-grid application. This is in standalone off-grid applications with the hybrid inverter. Here is how a DC coupled solution will look like. So the DC coupled solution, we have our PV system or PV panels connected to the hybrid inverter. The hybrid inverter now will have also the battery connected on the DC bus bar. So it's a DC coupled solution. The battery will be connected to the inverter on the DC side. That's why with hybrid inverters, we allow DC-AC ratio up to 200% because you are able to feed your load and at the same time charge your battery. That's why the hybrid inverters can allow up to 200% of DC-AC ratio. So we have the battery connected on the DC bus bar, so our PV system will also charge the battery simultaneously together with feeding the load. And on the other side, we have, of course, two types of loads. One of them is the grid connected load and one of them is the backup load. So in case the grid goes off, we have two ports. In case of the grid goes off, as we know, the port connected to the grid will go off as well. That's why this hybrid inverter has an additional port. It's called the backup port. The backup port is interconnected with your battery. So if the grid goes off, the on-grid load will go off, but the backup load will be depending on the battery to be fed. So we also call it, in other terms, emergency port. Why is that? Because some of the customers would like, for example, to put their full load on the on-grid port, but some of the loads are emergency loads. For example, let's say we are having some medication in the refrigerator. Let's say we need the air conditioners if the grid goes off. So all of those, we can connect them to the backup port or the emergency port, which is interconnected with the battery. So the inverter, even though the grid is lost, but it will use now the battery to feed the backup load requirements. So 200% DC-AC ratio, which is great. That means we have the same inverter rated capacity to feed the load and also the same inverter rated capacity to charge the battery as well. This inverter will have up to 10 MPPTs and each MPPT has 2 inputs, giving us 20 inputs. So big flexibility when we are designing our PV strings, 40 amps per MPPT. And in case we're having different length of strings, the inverter can withstand up to 300 volts of MPPT voltage difference. Also, seamless switching. So if the grid goes off or there's load shedding happen suddenly, the inverter takes 10 milliseconds to switch from on-grid to off-grid. And also it has 1.5 overloading capacities for the first 10 seconds. Overloading capacities actually is used when we have an off-grid application. For example, let's say the grid is not there and my system is carrying the full load, but some of the loads have very high starting current at the beginning. So the inverter can provide you with 50% overloading additional capacity for the first 10 seconds to support these high current loads at the starting point, and then it goes back to its normal operation modes. AFCI, which is the arc fault circuit interrupter, is also upgraded with the hybrid inverter. So we can detect up to 450 meters of cable length. AFCI is very important when we are having harsh site conditions, I would say. Maybe the cables have cut off somewhere, or maybe the connectors are loose or not connected properly, or because of the weather condition, they became loose. So arc can happen. Arc is an electrical discharge and it can cause fire risk as well. So the inverter is able to detect up to 450 meters of cable length. And also it comes with a patent pressure relief structure. So in case of maybe explosions happening, the inverter is able to release pressure from the corners, from the side. It has a pressure relief structure. So it will avoid the front side of the inverter to pop off. As I mentioned, we have the cell level monitoring and the pack lever replacement, which is very helpful, especially in the operation and maintenance. So if a battery pack or a battery rack failed, the other battery racks will continue to operate individually, independently. They will not affect each other. So each battery rack is isolated from the other one, and we can easily replace this battery rack with a new one. So we have a simplified maintenance and service ability as well, giving you lower LCOE and also OPEX cost as well. Here, moving to a very interesting part where a lot of I would say the installers or the end users are asking, what's the difference between the DC and the AC coupled? Because now both options are available. So the AC coupled systems are very suitable for larger scale C&I BESS segments, all right, and suitable for retrofitting to existing solar systems. It has modular pre-configured PCS and BSS cabinet. It has lower conversion efficiency, all right. When it comes to here's the typo. It has higher conversion, lower conversion efficiency, higher losses due to multiple conversion. Because what's happening right now with the AC coupled? The AC coupled, our PV is giving us DC power. Our inverter is converting this DC power to AC. Again, this power is going to the PCS. Our PCS is converting this power to DC to save and charge the batteries. And then after that, if we need the AC power, then again it's converted to AC and to be injected on the point of connection. So we can have multiple conversions over here of power. Therefore, the overall efficiency can go between 90 to 95% comparing to the DC coupled. And then there is a PV inverter as a model or as a unit, and there is a PCS for the power conversion, for charging and discharging the BESS systems. However, on the DC coupled, of course, it's suitable for smaller applications, all right? And it's suitable for new systems because this is a whole new inverter unit that you are installing. It's a hybrid inverter. It does the on-grid and the off-grid applications in one model. So it's more suitable for newer systems and smaller C&I levels or C&I segments. It's suitable also for smaller loads with large backup requirements, because with the AC coupled that comes with the PCS capacity is not changed. It's 125 kilowatt and the battery can be 257 or 510. If we need bigger battery capacity, then we're adding another model. So with adding the model with batteries, we are also adding PCS, power conversion systems as well. So that's why it's suitable for larger scale. But if my load is small and my energy capacity or energy storage capacity requirement is big, then the DC coupled is better, because one inverter, it has a rated output, for example, 125, but the battery, we can add the battery capacity, all right? Because one inverter unit that has the PCS capability inside, and then we can add up on the battery side, because the battery side, it does not include the PCS, it's built inside the inverter. So we have more flexibility in adding bigger energy storage capacity without adding more PCS capacity. Higher conversion efficiency due to the DC conversion from DC side to AC, approximately 98%. It's higher than the AC coupled. Why is that? Because the energy conversion over here is happening only one time. So when I have requirements or demand, then my inverter will discharge from the battery, convert to AC, and immediately inject it to my point of connection. Unlike the AC coupled, there's a PV inverter converting from DC to AC, pushing it to the battery. Battery, again, the PCS is converting from AC to DC, charging the batteries, storing the energy, and then again, when it's needed, it's converted to AC and then fed the load. But the DC coupled, the battery is directly connected on the DC bus bar of the inverter itself, and the energy is converted one time. So when it's needed, the inverter will send a command to the battery. The battery will discharge this DC power, the inverter will convert it to AC and inject it to the load side. So we have one inverter unit with integrated PCS feature in charge of the power conversion, charging and discharging the BESS. So by this, actually, we do summarize the difference between the two applications and the two product solutions. We also know when can we use the DC coupled or where it will be more beneficial for us, what kind of loads, smaller loads, newer systems, and when do we use the AC coupled. So for the AC coupled, I want to highlight with Sungrow, we can connect up to 20 units in parallel. So up to 20 units in parallel, if we are using the 255 or the 510, that's assuming we're using the 510, this is up to a 10 megawatt hour system. So this is suitable for bigger C&I system segments that are rated at 400 volts, while the DC coupled is suitable for the smaller segments. So by this, actually, we have completed the introduction of both of the solutions. We have gone through the recent energy transition and trends in the GCC region when it comes to maximizing the self-consumption. Some countries also had some load shedding. Kuwait in the past 1 to 2 years, they had some load shedding. So this application would be perfect to support the load shedding scenarios. Also, as I mentioned earlier, Bahrain also have now the net billing instead of the net metering. So we can, instead of, for example, injecting back to the grid with lower tariff rates, we can actually store our energy storage, our system output in the energy storage, and then use it on our load later on, and then use from the grid side whenever it's needed, whenever the battery is fully discharged. And it's also suitable for complete off-grid applications or on-grid and off-grid applications. That's where we mostly see in other countries. And specifically also in Saudi Arabia, there's a big demand when it comes to the energy storage on the C&I level, also on the utility level. So by this, we have concluded the latest innovation and the market trend and the catered applications. We can now open the Q&A section if there is any questions from our participants and attendees.
Thank you, Ms. Sola. We have one question from Mr. Balushi. He is asking if we are going with off-grid solution with PV operations and BESS plus diesel generator, then which solution will be better, AC coupled or DC coupled?
Okay, so actually both will work because both of them have the same objective. Both of them can work in on-grid, off-grid, switching between on-grid and off-grid. All right, but if the system, let's say for example, there's an existing PV system and later you wanted to add diesel generator or BESS, of course the AC coupled is better. If the system is big in capacity as well, because now the DC coupled is up to 3 megawatt, maybe your system is bigger than 3 megawatt, then the AC coupled will be better as well. But if it's a new system and it's small, perhaps it's like 125 kilowatt, 250, 500, 600 kilowatt, about that capacities, the DC coupled of course will be better. So it depends on what is my application and it depends on my system capacity itself. But both of them can work with diesel generators, both of them can work with off-grid, both of them can work with energy storage, off-grid, on-grid, seamless switching.
Okay, thank you. I hope Mr. Balushi, you have received your answer. Next we have a question from Mr. Vijay Soni. How much percentage we can connect at emergency load with AC and DC coupled system?
Okay, so the emergency load, Vijay, is actually based for the hybrid inverters, because the hybrid inverter itself, it has two outputs, on-grid and backup port or emergency backup port. So in this case, the emergency backup port itself, it has the similar or the same rated capacity of the inverter. So if my inverter is 125 kilowatt, then the backup port itself can inject up to 125 kilowatt. Yes, that will be the capacity that we can connect at the emergency load. But in case your system is fully off-grid, Vijay, this is of course a suggestion I always tell to our customers and partners. If my system is fully off-grid, make sure whatever you're connected on the emergency load is smaller is equivalent or smaller, preferably slightly smaller than the inverter capacity. Because in this case, the inverter will carry the full load by itself. There is no grid. Okay. On the AC side, we don't have an emergency load. It's one load point.
Okay, over to the next question from Mr. Jay Mehta. He is mentioning, in case of DC coupled system, is it possible to configure it to work as zero grid export system?
Yes, absolutely. So whether it's DC coupled or AC coupled, Jay, we can enable the zero export. So what we do, we install a power meter on the load, and this power meter, for example, in the DC coupled, will be connected to the logger or to the inverter directly. It will read whatever the load is consuming and tell the inverter, okay, just produce accordingly. Nothing extra will be produced. Therefore, this is a zero grid export application.
Okay, we have our next question wherein it is asked, what is the biggest capacity Sungrow has installed in a single site here in UAE that uses DC coupled battery energy solution?
So far, as I mentioned, everyone, this is a new inverter. So it's completely new, recently introduced to the Middle East and Africa region. So it have not been used here in the UAE yet. As I mentioned, because the energy storage application as an on-grid, it's still new here in UAE. Prior, we are using always, maybe until now also, pure on-grid systems when we are connected to the grid. But we are definitely going to see it, since the policies now came out in Abu Dhabi, that energy storage will be applicable when we are connecting to the grid. So later on, definitely there will be more installations, but we have installed it in Africa. Yeah.
Okay, thank you. We have next question asked by Mr. Asif. What is the capacitance rate of battery cabinet, whether it is one cycle or half a cycle for 510 kilowatt cabinet?
It's one cycle. Yeah.
Okay.
But also, everyone, the number of cycles, it depends actually. The default is one cycle per day, but sometimes some customers, they have different requirements. Perhaps they want to discharge twice per day, so that makes it 2 cycles per day. So it does depend on the end user or the EPC requirements.
Okay. Thank you. We have next question from Mr. Basam. The signal of the load shedding is depending in the current or any other variable?
So the signal of the load shedding, from the inverter perspective, the inverter will see it as, because load shedding is when the grid actually goes off in a scheduled manner, right? So the inverter or the solar system, solar C&I BESS system, will know that there is a load shedding, because we will lose the signal on the grid side. There's no longer voltage signal or frequency signal, so we will lose that part. So once that is gone, the inverter will know, all right, we lost the signal on the grid port. Now this is an off-grid situation, and it will do the seamless switching within 10 milliseconds to convert to off-grid and rely on the battery.
Okay, we have a question from Mr. Shabir. The questions are just popping in, and let me just read out how to choose a charging current suitable for the battery. In most lithium batteries, the recommended charging current is calculated for 2 hours, fully charging. Is it preferable to reduce the charging current to 4 or 5 hours charging?
So the charging current, Shabir, actually you cannot adjust it, because we are talking about right now the DC coupled or the AC coupled. So it will depend on the inverter. It will depend on the inverter output. So the battery is rated in kilowatt hour, and you know how much kilowatt hour you need in a day. Based on that, you will calculate your PV capacity that can charge this battery within your peak sun hours, and then you will design your inverter and your PV system accordingly to feed your load, or to charge your battery during this available peak sun hours. So it's going back to the design itself.
Okay. We'll just take up another 2 questions more. What is the warranty of the 𝗣𝗶𝗄𝗏𝗏 both battery cells and pieces?
So basically it's 5 years, 5 years standard warranty.
Okay, that's it. Okay, thank you, Ola, for your very fruitful presentation. We truly appreciate you sharing this valuable perspective of Sungrow solution. I'm sure all the participants has got a very good information regarding this solution, and I also extend my thanks to all the participants. And definitely please stay connected, and for your journey ahead we will be here. Both Power Sun and Sungrow is together to support you in all your solutions. Thank you everyone. Thank you for your time. Thank you for joining us. Thank you, Ola, for your presentation. Thank you everyone.
Thank you, Sinu, and thanks to all our participants.
And over email you all will be receiving your certificates.